One of the most mysterious lands on the Earth, a host to thousands of different species layered here within billions of undiscovered years of landscape. A legacy of more than 300 million years ago is shining here in the heart of Scotland. The sandstone casts of stumps of lycopod trees was discovered in 1887 and preserved exactly where they grew around 325 million years ago during the Carboniferous period.
Yeah, Carboniferous was a really interesting time in Earth history for a whole range of reasons. One of them is to do with the different kinds of animals that appeared and plants that appeared during that time, including the reptiles amongst the vertebrates. They weren't particularly important. They became important later on with the dinosaurs and so on, but they appeared during that interval. It was a time when forests really got going on Earth, and as a result of that, two important things happened. One of them was that there was a huge accumulation of plant material that we now see as coal, and in addition, this photosynthesis that the forests underwent produced levels of oxygen in the atmosphere that have probably never been seen before or since. And what that meant was that some land-dwelling organisms were able to grow much larger than they can in the present-day oxygen concentrations of the atmosphere.
Fossil Grove is one of the most famous in-situ Carboniferous forest examples in the world. 11 stumps of lycopod trees are preserving Scotland's millions of years of mystery.
The trees that are seen at Fossil Grove belong to a group of plants that their nearest kind of relatives, that not descendants, their nearest relatives are things called club mosses today. And these are small things, a few centimetres high. But this particular group in the Carboniferous period were able to grow very, very tall because they developed a very thick bark. Not very much wood inside that bark, but a very thick bark. So these trees were able to grow 10, 20, 30, possibly even 40 metres high, really strengthened by this very strong, this very sturdy bark.
The Fossil Grove has been designated as a site of special scientific interest by the Scottish National Heritage. It's the oldest example of conservation of a geological site.
Every kind of rock tells a story. Here we've got two kinds of rock, the mudstone in the building that's entombed these trees and turned them into fossils. And you've got rock here in the quarry, which was actually solidified from molten magma deep within the earth. And it just so happens that the way Scotland formed is made up of an incredible variety of those rocks over just a phenomenal timescale. So that means we've got an incredible variety of those stories as well. Put all those stories together and you begin to understand the history of the earth, and it helps us understand the future of the earth as well.
This specific tree genus could only grow in a tropical climate. It consequently reveals that Scotland was much warmer than it is today.
At that time, Britain was close to the equator. It was in the tropics, and so the climate was very much a tropical climate. So here it was hot, it was wet, and for much of the time here in the Midland Valley of Scotland, the environment was a land environment, periodically being drowned by the sea.
Surprisingly, the land in Scotland has been drifting thousands of miles from the equator to where it is now, which is the main cause of the climate change. Geologists are convinced that continents are still moving apart, and there's evidence to support this.
That through time, the oceans, the continents have moved and changed through geological time. So it's because of plate tectonics, that the moving of plates on the surface of the Earth, that nowhere remains the same forever in a geological sense. So through the last 400, 500 million years of geological time, the area that we now call Britain has moved progressively northwards from some of it quite a long way south of the equator to its present quite high latitudes. So at the moment we are in Britain here, we are drifting apart from North America. So the Atlantic Ocean is an opening ocean, so we are spreading apart from North America, that distance increasing by about 3 centimetres a year. Enough to be measured. Satellites can measure this over a sufficiently long period, so we can calculate it, but we can also actually measure it now. So at the moment we're drifting apart from North America, whereas at the other side of the world, the Pacific Ocean is closing. So part of the Pacific Ocean is disappearing around its margins, which is where you get these terrible earthquakes around Japan, and in East Asia, where you get volcanoes and earthquakes along the western edge of South America.
It's wonderful how, with the power of science, a piece of fossil or rock can be a window into 1,000,000 years in the past or future. It's so sad and surprising that Fossil Grove is closed for half of the year due to lack of visitors. What can really draw attention to this treasure?
For me, I think drawing more attention to the site, you can do things to the buildings and the signs and so on, but what really matters is making the links for people between the story of the rocks they see here and what's going on in their lives elsewhere and things they learn about elsewhere, whether that's at school or other places they're learning. So, for example, if you can picture yourself in this building walking through this grove of trees as they were rotting in the mud, that makes it a little easier to understand how 300 million years ago there were countless plants turned into coal, and that coal, of course, powered the Industrial Revolution, and that's what transformed Glasgow utterly. So whatever is done to draw attention to the site has to focus on those links and help people understand how the geology here links to other parts of life.